I want to talk to you about some of the most unwelcome visitors in the history of ever. Not invasive species or bed bugs or telemarketers. I'm talking about asteroids. Specifically, the kinds of asteroids that hit our planet and make a big mess and kill a lot of things. You see, a group of astronomers and physicists, and probably some savvy promoters of disaster movies, have declared June 30th to be Asteroid Day. A day to raise awareness about near-Earth objects and how some of them can get a little too near Earth and create some really bad days. The organizers of Asteroid Day decided on June 30th because that's the anniversary of the infamous Tunguska event, when, in 1908, a giant something, some say it was an asteroid, others a comet, exploded over Siberia, leveling 2,000 square kilometers of forest. But the funny thing is, there have been many more, much bigger impacts caused by felonious flying space objects, but most people haven't heard of them. Like, I'm sure you're all familiar with the recent Unpleasantness in what's now Mexico, where a giant rock some 10 kilometers across smashed into Earth, leaving an enormous crater in the Gulf of Mexico called Chicxulub. That happened 66 million years ago, and it's what most paleontologists think was the leading cause of the extinction of the dinosaurs. And I say recent because, geologically speaking, 66 million years ago is not very long ago at all. Practically the day before yesterday. But there are even bigger impacts that happened hundreds of millions, even billions of years ago. And even though some of them are catastrophically large, they've been hard for us to discover because the scars they left on the land have been smoothed out by eons of geologic activity. That's why it wasn't until the spring of 2015 that scientists discovered signs of what's probably the biggest asteroid impact ever found. More than 300 million years ago, an asteroid came screaming into what's now Central Australia and broke into two, each chunk more than 10 kilometers across. Together they slammed into the surface, but instead of making two huge holes in the ground, they actually created domes. The rock smashed so deep into the Earth's crust that the mantle below appears to have bounced back up, forming upwellings of rock. Researchers stumbled upon this discovery while they were drilling for a geothermal project and came across a layer of shocked quartz. Quartz rock whose structure was realigned by the enormous pressure of a meteorite impact. After mapping out where this quartz was located, the scientists ended up finding the outline of two impact zones that cover more than 400 kilometers. We still don't know when exactly this collision happened or how miserable its effects were for life on Earth, but this Australian double punch takes the prize for creating the biggest impact features on the surface of our planet, at least that we know of. Before that discovery, the largest known impact crater was also the result of the oldest known collision, the VREDEFORT impact in South Africa. Just over 2 billion years ago, a rock about 10 kilometers across came careening into the landmass that would become Africa, forming a crater more than 300 kilometers wide and 10 times deeper than the Grand Canyon. The collision created such enormous heat that it melted the crust of the Earth, forming a lake of magma, and it ejected vaporized rock that rained down all over Russia and Northern Europe. Now, life back then was pretty simple. Like, if you were a cell with a nucleus, then you were the bomb. So we don't really know the full extent of the damage caused by this collision. But we know that it happened because VREDEFORT has its own telltale dome at the center of a faint crater, and tons of distinctive black rock where its magma lake cooled. But why should the southern hemisphere get all the excitement? No survey of the planet's most severe spankings would be complete without a trip to Ontario, Canada, and the Sudbury Basin. The basin's what's left of an enormous crater, originally about 250 kilometers across, making it the third largest impact feature on Earth, and, at 1.85 billion years old, also one of the oldest. But until recently, scientists weren't sure what kind of object made this crater. It was only in 2014 that geologists found that the rocks around Sudbury had unusual chemistry. Asteroids tend to be rich in elements known as siderophiles, or iron-loving metals like gold, nickel, and platinum. But there weren't enough of these metals in the Sudbury rocks for the impacts to have been caused by an asteroid. So instead, geologists think Sudbury was hit by a comet, a gigantic ball of ice, gas, and dust that vaporized before it reached the surface, creating the crater with its shockwave, but leaving behind very little in the way of rocky debris. But to be honest, if you happen to be some ancient Canadian single-celled organism, or a dinosaur, or a Siberian tree, it doesn't really matter what caused these events. What matters is that over the past 2 billion years, we've gotten a lot better about spotting menacing objects out there before they punch us in the face. And if need be, hopefully we'll be good at stopping them too. Thanks for joining me for Asteroid Day on SciShow Space, which is made possible by our patrons on Patreon. If you want to help us us make this show possible, just go to patreon.com/SciShow. And don't forget to go to youtube.com/SciShowSpace and subscribe.